Hello and welcome to a ramble about the department's May 2022 paper 2, question 9.1 today. In the diagram, DEFG, okay, so, Euclidean geometry, I'm going to follow along with my little pointer, is a cyclic quad. Thank you for letting us know. With DE parallel to FG. Okay, so we're seeing some alternate angles, maybe some co-interior angles. Right, alternate angle there, who knows. DE is produced or extended to R, so this is a straight line. T is another point on the circle. Okay, so we've got some angles in the same segment maybe. EG, FT, and ET are drawn, okay, all straight lines. E4 is 72 degrees. This is an exterior angle to your cyclic quad, so that might be good to know. And G1 is equal to 16. What does that have to do with anything? I don't know. This chord subtends this angle, but no other angle. Okay, right. No center of circle mentioned, so that chops a whole lot of theorems. Maybe not a whole lot, but you know. Determine with reasons the size of the following angles DGF. DGF. Okay, so this is, yeah, that exterior angle relationship that we identified. So DGF is equal to 72 degrees. And I'm going to write the reason below and then I'll move it. But exterior angle of cyclic quad, and I'll just name it DGFE. Okay, will be equal to the opposite interior one. Okay, shrink it even more. Shrink it. Okay, righties. So that is 72 degrees. We now know that. And in fact, we can just write that this little guy over here is 72 degrees minus 16 degrees, which is what? 56 degrees, I think. Okay, is this guy. Right. Okay. Then angle T. Where are you? Angle T. So here we have our angles in same segment. Okay. So I hope you can see how useful it is to just kind of, even before you launch into these questions, as you're reading the question, kind of get a sense of what's going on. What are the relationships in this diagram with each piece of information that is revealed, right? I just think it makes life a bit easier now when you actually need to solve. So 9.1.2, and to be fair though, this is one of the simpler Euclidean geometry questions. It's probably like one of those questions where it's 2 marks, 2 marks, 2 marks, just to warm you up. So this might work for simple questions and not work for big questions. Who knows? Angle T is the same as angle G2, which I have already worked out, but we can just write down again for the people. Maybe let me put the reason first. Angles in same segment. Don't really have to say which chord is subtending them, but yeah. Subtended by chord EF. At least if you're clear, you know, your examiner can see where you were trying to go. So 72 degrees minus 16 degrees, which is 56 degrees. And now I've just used up all the space in the world as if I don't have a third question to attend. Oh my goodness, what is happening? Oh my wet, oh my wet. Okay, let's try that again. Right, we'll do the last one in a different color. Okay, but let's fill in what we found out now. So we found out that this guy is 56 degrees as well. Okie dokie. And then the last question says we must work out the size of G, E, F. And we haven't used our parallel lines yet, so maybe this is the moment. G, E, F. How to do it? So, you know, there's that alternate angle happening here that would give me this, and then angles on the straight line would give me that guy. Is there another way? So this angle is being subtended by this chord. This chord isn't really doing anything else, so that's a bit of a dud. This, oh, we could also use opposite interior angles of cyclic quad if you want to be fancy, but potato potato. Either way, we're going to need to figure out how big this part is. And I think for this, we definitely have to use the alternate angles. Don't know what else you could use. This chord subtends that angle, but it isn't really doing anything else. So yeah, let's do that then. So we're going to work out the size of this angle using alternate angles. So 9.1.3 angle E1 is equal to 56 degrees, and that's because of alternate angles on the parallel lines ED and FG. Okay, so now we know that that's 56. Okay, and then to get this guy, we can use angles on a straight line. So GEF is equal to 180 degrees minus 56 plus 72 degrees. Just going to move you a little bit. And that's because of angles on straight line. What is the straight line? DR. Okay, that line over there. Okay, and so this is not in the mood, not in the mood, not in the mood to hurt my brain. Okay, it doesn't hurt the brain. That's propaganda. Anyway, so GEF is 52 degrees. Let's see what the memo thinks of our endeavors. So we have 72 degrees for the first one, good. Next one, 56 degrees, good. Last one, 52 degrees. Perfect. I'm just trying to figure out something they said here. So their first approach was using angle sum of a triangle, and I'm not sure how. So I'm just going to follow along with the solution. So this is for GEF. First, they said, okay, E1 is equal to 56 degrees because of the alternate angles. Okay. And then they say, no, that's not what they started. Sorry. I'm doing my solution now. Okay. So their solution says F1 is equal to E4. Oh, alternate angles. So then they have a 72 there, and then they do angle sum of triangle. Get that one. Clever, clever, using of brain. So that's cool. Yeah, one of the nice things about writers, so many different ways to arrive at the same answer. Amazing. Thank you so much for pulling through. Um, 2 questions to go for me from this exam. See you in one of them, maybe.